Can you upload the video before this today? Is it possible?
Huh?
Can you upload the video before
No.
this?
Top day today, maybe not.
Any way to procure it?
You can pay me.
How much? It's a bribe-driven academy.
I mean, how come it's a bribe if we are on the same position? He's a student. Like, I'm not his professor.
Okay, it's a transaction-driven academy then.
No, it's still bribery if you get somebody paid.
Oh no,
No,
It's just paying.
If you were going to upload it anyway, he's just getting it faster.
Yeah,
Well,
it's
he's
just,
still just paying. Yeah.
so no one would do something. $10 an hour, they'll upload it.
Can we collect $10, please?
Okay, so today we are going to talk about FlowDroid. It's an analysis tool which helps to find security vulnerabilities in applications. First, we'll have a brief introduction about previous work, about how Android applications work, and then we'll see how they model the life cycles in Android, and then we'll talk about flow-sensitive analysis that they have implemented, and at the end, the evaluation part. So today, like almost everybody uses smartphones. So, and all of us keep private and confidential data in it. So it's a good target for attackers to gain the information they want from our phones. It may either be like carelessly programmed apps or apps that are malware and produced to do that. So either of them can be dangerous and leak our data. So in this paper, the approach they use is called taint analysis, which the big picture is that they have like these sources of data that are important, and they will look for the things that lead to get this data out and detect them as vulnerabilities. So the the previous work consists of dynamic approaches and static approaches. In dynamic one, they had the negative point is that we need to have many tests to have high coverage and detect everything. And also these monitors they use to like monitor the application's behavior. It can be detected by malware apps, so they'll just pretend for now that we are being monitored, everything is fine, and they don't do anything bad. And so it doesn't work that way. And also we have static approaches, which, as we know, will lead to imprecision. And they were mostly coarse-grained over and under approximations, and also the previous work lacked of life cycle modeling, which is important in Android applications. So they came up with this plan called FlowDroid, and it tries to do the static analysis precisely, which we'll see what techniques they use to achieve that. So what are the challenges? So the first challenge is that they need to predict the application's control flow. One of them is like life cycle modeling and also callback integration, which we will see in a bit how they're related. And also sources of sensitive data. For example, in a user interface, we may have password fields which are sources of important data, and they need to detect them, which are not pretty much easy. And also aliasing. So in regular Java programs, they use kind of a context and object sensitivity to achieve that. But in Android, they need a more deep aliasing analysis to make sure they find everything.
I have a question regarding these password fields.
Mhm.
So, I believe in, maybe you guys know more, in Android application, it is possible to create an app, it will be service. And what if this app will do scanning for these passwords? So it's like a LastPass application that is capable of like filling up the passwords and logins, but it does malicious intent that it's captured where you once you enter the password and will send it out. So it will be like a third-party application, and it would it be detected as a malicious?
So the point is here to detect that application, you know. So like whenever an application is produced and they want to release it, they do this analysis on it to see if they cause any leaks. So I think it will be detected.
There are a few different issues here. One is if, and they get to the issue of who's going to use this tool, why are they going to use it, and what is the notion of sensitivity, right? So in order to have something like this, you need to be able to recognize that this is a sensitive input. This is something you care about, like a password, like identifiable information, right? Because those are things that you don't want to leak. And the idea behind taint analysis is that you can detect those leaks. It's part of what we call information flow. You want to make sure you're not losing information, making your information inferable by someone else. And so what's critical to this is being able to know what information is important. And so if you're looking at your own app, you can ask yourself, is any of this information that I consider sensitive leaking? If someone else is phishing, which is what you're describing, right? Where they're creating something that looks like a particular app, but it's not.
No. So it's a app that runs separate from your main app. So it's kind of like a scanning that you're about to enter a password in the field.
Okay.
And once you hit enter it.
Okay. That actually will be caught.
Will be caught?
Yeah. Or could be, yeah.
You want to install it first, right? So it should be available somewhere, so they don't put it in Google Play unless they make sure it's not malware. So they use this to detect that.
So essentially, what you're describing is two things that are part of the same application, right? They're part of the same APK or Android package.
No, could be different.
If they're different, then they can't access each other's information. That's just provided by the underlying security operating system, right?
How then LastPass is capable of entering the password on your app?
How then what?
LastPass, there is
Okay.
application, and it's essentially you open your Facebook app, you forget the password, LastPass will offer you to enter it.
Okay.
Using
It wouldn't be entering, in that case, you're not entering. LastPass has your password stored. So LastPass has
it
your
does. The issue there is that this means that it's reading it somehow. In this case, you're essentially saying that you trust LastPass, right? Because it comes up, and you have to enter your password into LastPass, I presume. Yeah. So you're explicitly entering it in.
But then it's possible then to
So you
create.
have a master password for LastPass.
Mhm.
Once you enter the master passwords, it becomes on. So after that, whichever password you enter, it will offer you to save it in LastPass automatically. So it will, as you enter the fields, it will automatically read them and ask you explicitly, do you want to save this? If you save it, next time whenever you open the app, you can instantly fill the passwords using LastPass. So LastPass will automatically fill it for you. You don't have to do anything.
That's
It's a safe application, generally known for not transferring data into the cloud.
sure.
But that means it's possible to create like bad pass that will.
Yeah,
Do
that's
similar
disconcerting. That's I haven't actually used it.
Okay.
I don't think the
I'm not sure what the
LastPass
model
has
is.
access to the first program's data.
You're saying that it can see what you typed, or you just have a master password?
Yeah, so once
that
you enter
fills
the
in
master
things
password,
automatically?
it becomes on your browser normally. And whenever you
Oh,
open Facebook or anything, it will
Browser-based?
automatically.
Browser-based
It's
or app-based?
It's browser based, which I have used. I think he's saying you can also
Right,
use
right.
an app based.
It does have an app-based version?
Yeah,
You know this?
Yeah.
Okay.
You
Huh.
can see it.
That's interesting.
But-
I would take a look at it. This is, I guess, a bit of a distraction.
Right.
But in that case, if it is a separate app, it wouldn't be able to detect it because it wouldn't be flagged as sensitive information.
But I think, why? Because it's looking for sensitive data, so it can.
So the question is, what is sensitive? You have to figure out what you're flagging as sensitive. And
So they're detecting password fields as sensitive data.
okay, but this means it needs to know what a password field is. And if LastPass doesn't flag something as a password, just uses a normal text field or something like that, then it might not be flagged as a source of sensitive information.
What are you analyzing though? Are you analyzing LastPass or are you analyzing the first program?
You end up, presumably you'd be analyzing the first program.
So if LastPass enters,
It's kind of a man-in-the-middle attack,
yeah,
which is intrinsically somewhat difficult. But this gets to the notion of who are you analyzing and what is considered private information and what is not, which isn't really as much part of this paper.
So it's just one of the places where their approach will work.
though I think they didn't mention that they assume that Google security policies are valid and working.
Yeah.
And I think Google security policy kind of,
They have
generally.
some assumptions
Yeah.
about that. Can
Yeah, I'd actually have to look at what's going on in that app to be able to say anything. But we can continue on for now. But this is something interesting where, you know, if there's someone who's pretending to be something they're not, and they're separate applications, then you can't detect.
So their contribution is implementing Flowdroid, which is the first fully context flow field object sensitive approach. And also they've done lifecycle modeling and callback integration. And also they claim that there was not a benchmark available to test their approach, so they developed one. And,
for Android.
and yeah, so it's called Droid Bench and it's available.
So before we move from this slide, that first bullet point there, context, flow, field, object-sensitive approach.
Yes.
Are we going to go through those?
Yeah.
I don't recall.
Yeah.
We are. Yeah.
We will. Yeah.
Okay. At least some of the people should remember though, right? Do people remember what context-sensitive is? I hope.
What is data analysis?
Okay, we'll come back to this as well, but it's just in general, the idea of you have some sources of sensitive information, and you want to determine if that information ever flows to a point where it could be sent out in an unsafe fashion, sent out to someone you don't want it to.
Okay. So first we'll have a quick background on Android, just to make sure everybody knows a little bit about what's going on. And so Android components are mainly activities, services, broadcast receivers, and content providers. So the main thing that we are going to talk about today are the activities. Services and broadcast receivers are they are running background. And the content providers are related to databases, and we're not going to talk about them as they have not done it in the paper as well. So when you're developing an Android application, you have kind of two types of files: the Java files and the XML files. The XML files are mainly for defining the user interface. And also you have a manifest.xml file that contains the main configurations of the app, and we will see an example of it. So first of all, activities. So what is this life cycle thing that they're talking about in this paper? So when you create in Android application, almost everything is that you see is activity. So when you wanna implement it, you extend the activity class that is available in Android, and then override its main functions that are its lifecycle function, like onCreate, onResume, onPause, onStop, and everything else. And they'll be called automatically by the OS. So the activity is alive till the undestroy function is called in it. Yeah, and its life cycle. So here is an example of manifest file. So all the activities are registered here. If you have services, we register here as well. And also it contains all the permissions that user gives to the application. As we see here, user's permission. I don't know what's like this one, but for example, we have permissions like read context and like, I don't know, like lots of other permissions as well. So the user should be like, be careful when, accepting the permissions that that the app is asking for.
So
we'll see.
I've heard that this permission model is kind of broken.
Yes.
Because, and people say it's completely broken because, let's say, Angry Birds developer Rocket made a new game. And they're asking like whole bunch of permissions from you.
Yeah.
You really want to play game? Would you
Yeah,
say
that's
no?
true. Everybody accepts them, but so what they're trying to do here is that they try to like look through these permissions and see like what's going on to see if the app is.
Yes, and Android also looks through permissions and gives you the list. And you can now before you couple permissions, now you can even scroll it up and down because apps requesting so many permissions.
There's actually a lot of research going on just into mobile permission management.
Yes, I'm aware of it. People talking.
Yeah, so we'll see how they come to play. So as a simple interface, so we have like a text field and a button. So here is the user interface that we see. So what's the code behind it? So the XML file, the button thing is so it's XML and it's for UI. As we see, there is a attribute for it. On click equals to send message. So what it means is that when you click this button, this a function with this name is called. So I think it's a callback, what they're saying in the paper. So so in the Java file, we have this thing. So we have a function with the same name as there, and as an input, it takes in a view. So and like a simple implementation will be like this. So how they find that button is by find view by ID, that it has an ID and it takes it, and now they have this component that they can like work with it and do other stuff.
Is callback only a function pointer passed as an argument? That's it?
How many people have used listeners in Java? Okay, I imagine most people should be raising their hands.
Because it
Obviously.
gives C#.
Sure. Like, in order to listen to button clicks, right?
Register the data.
Yeah. That's all this is. It's just that you can specify it both by adding in a new object that is the listener,
Okay.
or by specifying it in the XML. Like this. Yeah, it's exactly that way.
Yeah, no difference. So here is the motivation part. So this is an activity from a malware app that tries to leak your password out. So what happens here is that we have a password field and the username one. So first it finds them by ID and it gets a string from them, and this is in on reset method of the lifecycle. So every time the activity is resetted, this function is called. And then when you click the button, the callback to this function will be called. So here it takes both fields and tries to do some kind of decoding with the password, I guess, to make a new string so that we can think that it's not the password leaking out. So if
No. It's just that the
No?
password you cannot get the string, password string entirely. You have to go character by character.
No, but it's concatenating it with
Yeah,
something.
So it's the reason they say obfuscated for the variable name, which is
Obfuscated.
horrible. Yeah, it's obfuscated passwords. So
Yes.
all they're doing is adding underscores between the characters.
Yeah, and so it sends this through a SMS manager, and like so this data is like leaking out, and we don't want that, right? So it may go to like bad sources. But so the point here is that if you wanna do a like simple analysis which doesn't count the semantics, it doesn't work because it cannot detect this kind of decoding. So so the motivation here is that our analysis should be semantic aware, and it's not that simple, I guess.
Can real applications have such a, like, is it a fabricated example?
This is a simplified example.
Yeah, but I think it's from a real thing.
Yeah. So basically, I believe you have to be very careful when the app requests permission to send messages, text messages. It's very fishy, especially if it's not primary.
Even if it's not sending your information, it still costs you money every time they send something in data.
Yeah, you can send the premium numbers. Another thing, how do you think, would this tool be able to catch the following when they will send these SMS messages only if you are in particular country, only if the phone is registered for particular country? I've seen the snippets of the source that they will send only if you have Russian mobile operator. Yeah.
So it's static analysis.
So,
So what does that say?
would the static analysis be able to catch?
Should it? Should it be able to? It's static analysis. Does that tell us anything?
It will over
Um,
approximate.
We can. I don't understand your
Yes,
example.
it should, because it would know that you're still sending a message. It won't see that what country you're in. It'll see that the message would be sent.
Right. So it's over. The question is, if you have an if statement that says if we're in Russia, then send this SMS message, right?
Yeah.
Will it be able to detect that? And we've seen that it should be able to. Yeah, because with static analysis, what it'll say is, I could take either path. What happens? Conservatively.
Yeah.
Can it?
So that you should be able to catch.
Yeah. Okay, so any questions on the example? So they have these assumptions about their attacker model, which I felt we should discuss it.
I'm sorry, I have one more question.
Sure.
What if these operations of getting a password and sending a text messages are split apart in time and activities? What if you have two activities in your application, and one is just capturing the password and hiding it in the variables?
I
And
don't
then
think
we-
that matters, that they will detect it. Because they go through all these activities, and we'll see in a bit, their assumption is that the activities can happen in any order, so they should be able to, I think.
So yes, as long as those activities aren't in separate applications.
So do they actually check for the where the message is being sent and what is being sent and then trace back to?
We'll see. That's the point. We'll see.
So the attacker's
It
model.
takes it from forward and backward. So
It's okay. So they assume that the goal of the attacker is leaking the private data using the permissions, and sorry, I think that's a mistake. Breakdown into smaller fragments. Okay, the assumption is that they assume that there's no way of circumventing security measurements of Android platform, as we talked about it earlier, and there's like they cannot the malware cannot do some implicit flow analysis, something to disguise this analysis that we are using. So
Has anybody ever heard of an implicit flow before? Has anybody ever heard of a covert channel before? Okay. What is a covert channel? Which is what they also mentioned, tied into implicit flows.
well, basically something like a side channel.
Okay.
So that would be a good channel.
Sure, so you've got some way of sending the information without actually sending the information itself. Yeah.
Undercover? Undercover?
Kind of, undercover, yeah. Yeah. And that's kind of what implicit flows capture. In fact, we can almost reason about what implicit flows should be just by looking at what taint analysis is. We've seen the concepts that fall into taint analysis. I said that it's detecting whether or not there's, well, multiple people here have said that it's detecting whether or not there's information that flows from some sensitive source to some sink, some potentially public output. What is that related to that we've already talked about?
What is like a call graph flow? No?
Well, it doesn't have to be call graph. We're looking at information flowing from one point to another.
Comes from the artifact.
Tracing?
Context sensitive.
Okay, it's something we might have discussed early on. After representations,
Oh.
information flowing
Dynamic.
from one point to another.
Yeah.
Okay,
Throw that word out there.
I like that one. Now there's something else as well.
there's something between these, between representations and data flow. We talked about slicing, right? We talked about slicing.
I knew I had to speak out this.
You
Always
said,
comes back to-
I saw you start. I saw you start, and then you stopped, and a single tear rolled down my cheek. It also stopped halfway. It's related to slicing, right? But we're looking at the data flow in slicing. We're looking at the data dependence graph, and looking at paths through the data dependence graph, which maybe you were going to come back to.
Sure.
Perhaps, maybe. What might implicit flows be?
On mobile app?
In general, implicit flows. If taint analysis looks at,
So if there is something which slicing cannot handle,
well, slicing might be able to handle it.
like a power a or x power x.
Taint analysis looks at data dependencies. Implicit flows are generally produced by control dependencies. So for instance, you could say, if the first character is C, you could broadcast, send a message 3 times, and then you could send some other message to say, we're breaking between the characters. If the next character is D, you could send a message 4 times, and this wouldn't necessarily be able to handle it. Their assumption is you don't have something like that, where there's no data connection, right? The control dependence is what's determining whether or not there's some other message being lost.
And that's not covered.
Right, that's an implicit flow.
Okay.
I don't understand. You're saying control dependencies are implicit flow?
Right.
Oh.
So
So implicit flow is when there's no data transferred, but yet the information.
there's still data, but
Not
it's not
related.
it's not tainted information. There's not a direct data dependence flow, but from this tainted source to the sink.
So when you say send message 3 times, if you find a character D, it will send that message from a particular variable which is tainted.
Yeah.
And what
No,
they say
not
is,
necessarily. No. So that's
Is it like encoding, like if you get some characters, send this 3 times, and then you decode at the other end? Like
Yeah,
the message
yeah.
is received 3 times.
In that regard, the data was never sent,
No, yeah.
but the information was sent, right?
okay.
Actual data was never sent.
So, C is a horrible name for a variable. Let's
Yeah.
say
X.
oh, that's not effective.
I'm sure it's a dry erase.
Yeah.
I mean, it rubbed off with my finger, so I can at least get rid of it afterward if I want to.
Yeah. Okay. It rubbed off and your finger when it was wet.
If worse comes to worse, I'll just write over it with dry erase marker and erase it afterward, because that always works. the alcohol in the dry erase markers peels off permanent marker. Anyway, so little tricks are good to know. So if password 0 equals C, right, you could say
Right, too much.
you could even have something like this. Hi, nice to meet you when the password equals C. And then if it equals D, send how are you? Something like that. Send a different message. There's no clear connection in the data dependencies between this value and what you're sending.
Wow.
Yeah.
Interesting.
But
It's
this
an implicit.
Well, why not just send a number?
This is very nice.
Send one
You
first.
could use it somehow.
This is harder to detect, right? This is implicit.
okay.
So there's kind of an encoding going on here.
Yeah.
And these are the kinds of things you have to care about when you're dealing with security. I mean, this is again a rough introduction to case analysis, which is another core analysis technique. But it's very much related to slicing, right? We're just looking at data dependencies.
So, to take this example to the extreme, if you have a while loop that goes over your entire password
Yep.
through each character,
Mm-hmm.
and it says if C, then send C. It's C at the top of the password is related to password. Send message of the character C
Yeah.
is not related to the password. It's a completely new string.
This is true.
Yeah.
They are not data dependent.
This is true.
So that's an implicit.
That's also pretty easy to find. But yes, this is
This
true.
would not pick it up.
Technically, no.
Yeah.
I should say that pattern is really easy to find.
Yeah, I would hope so. I would hope that Google's automated. Yeah.
You can send emojis instead. That would be like innocent.
If you do something a little more clever, it's easier to track. It's easier to fool them. Just a little more clever.
I like that. That's cool.
So now we're going to talk about this modeling of life cycle. So why this is hard? First of all, because we have multiple entry points in the application. Whenever you define an activity, it can it can be like a main function. It can come up at any time. So it's not like a single program that we have in Java or C that has a single main function and we can track everything from that point. So how they dealt with it is that they decided to construct a dummy main method from the activities. And the other challenge is asynchronously executing components. So like activities can happen in any order and can be in parallel as well. So for example, when you're like looking at the UI of your application, in the background there is service running, like sending data, do like background work. So both of them are in parallel execution. Yeah, and things like that. So we need a model that is not path sensitive because we have like lots of paths and we'll have path explosion if we do it like statically. So they came up with this plan to use IFDS model, which the whole point about IFDS is that it joins analysis result immediately at any control flow merge point. We'll talk about it and illustrate it later on.
So what? Oh, question?
Yeah, the IFT is inter-procedural flow function.
It's interprocedural finite distributive subset problem. Something.
I read it as simple as something else in the paper that we had done.
It is very much related to stuff we've done. It is an approach to interprocedural analysis. It's an approach to what you saw in Project 2, except it's a little bit more theoretically complex, so we didn't go through it. I went through a slightly older approach to interprocedural analysis, which isn't as used in practice, but is a little bit more general. If you have more structure to your abstract domain, if you have more structure to your underlying problem, then you can use this approach to interprocedural analysis, and it'll give you precise results more efficiently.
Yeah, and they made like a slight differences to IPS, but we'll see. We are going through the algorithm. So the other challenge is about the callbacks. So as an example, when we are having location updates or UI interactions, they all will cause callback. As we see an example earlier, when we click a button, there's a callback to the function that implements it. Yeah, and also with callbacks, any order of occurrence is possible, so they'll be hard to deal with. So how to find registered callbacks? So a naive approach is to scan the classes and see which one implement the callback interface and keep track of them. But they have an algorithm in the paper, which I'm not sure if I understood it correct, but so they'll construct this call graph per component. So for each component, they'll start at like the overwritten methods like onCreate, and then they use this call graph to scan for Android syscalls, and they extend this call graph incrementally, step by step, and then they'll see if they have achieved the fixed point. If yeah, okay, done. Otherwise, they'll like recompute the call graph and so on and so forth. So they claim that this approach is more precise than the naive approach. So I don't know why.
Do people see what the naive approach is doing? Okay, it's scanning everything. Yeah, in Android, you know which things are callbacks because they have to implement certain interfaces, right?
Yeah.
So you can just look for those types, and that will tell you. And this is one of the approaches that you might have taken to Project 1 for building a call graph, right? Looking at the types of things in order to build a call graph. And naively saying, hey, we've got one type, anything that calls a method of this type, satisfies that. Throw an edge in your call graph, so forth. Maybe ringing some bells there.
Isn't that good now? Why is it imprecise to have the other approach?
Why is that imprecise? Thoughts? Why is that imprecise?
Because it doesn't necessarily mean it actually.
Several callbacks. What if you have one button? Might theoretically have several callbacks depending on the if statement. You can assign to one button. If one, assign this callback to the button. If two, assign that another one.
I think
It's
then
quite possible to do that.
when we go through, okay. I think maybe because in Project 1 we saw like separate call graphs for stuff, maybe figured out the connection between them.
So part of this gets to the notion of precisely knowing which points could potentially call which other points. And if you have more information about the flow of things, you might be able to say, well, only certain callbacks actually reach a certain point in the program, so those are the only things that are meaningful there. That's a little bit helpful here, right? Where you have some additional flow information that tells you which callbacks can be called from a certain point.
So, like the naive approach, if there was a callback in an if statement that says if false, so it would never be called. The first one would say yes,
that would also happen, right?
This call would be called, but yet it would actually, if you look at the code, it would never be called because it's false. The second algorithm would realize that.
Yeah, so there are two issues here then. One is dead code, which is what you're describing, right?
Yeah.
And the other is being flow sensitive, which is that in order for a callback to actually be called at a certain point, for it to be called in response to a certain thing, well, whatever that callback thing was, whatever that callback object was, it must have been possible to pass that down into the callback registration function or something like that. I don't know if they focus on that part quite as much, but it's possible. Both of those can feed into ways in which this is more made more precise. Why do they have to go to a fixed point?
Just to make sure they've covered everything. Oh, you mean maybe we don't reach a fixed point?
Oh, no, you should reach a fixed point, because maximally you know there are only as many potential callbacks as there are classes that implement the callback interface.
Yeah.
So there's a finite upper bound, so you'll reach a fixed point. As long as you have a finite upper bound, you will reach a fixed point.
Yes.
Well, why do they have to do that?
To make sure they have included everything, like as many of information that they can include.
Is it possible they don't include everything right away?
Yeah, because it's nested, right?
Okay, yeah. So the issue is that you could have callbacks that themselves add callbacks. And so there are these interconnections between things, yeah.
Okay, so now we'll discuss about how they implement this flow sensitivity and other sensitivities as well. First challenge, how to implement high object sensitivity to resolve aliasing effectively. So we are now going to talk about the aliasing detections, and we are going to use forward-taint analysis and backward-taint analysis. We will see here in an example. So what's happening here is that okay, so here they're saying that we have some information from source, and it's going out from sink. So first step, from the source, they're getting some information and put it in W. So they'll keep track of W forward until they hit a point which they are allocating this information to a heap object, which is here x.f. They will follow x.f separately, but here we need to do something. Whenever they hit a line that is assigning something to a heap object, they'll go backward to find their aliases. So here they'll figure out that step 3 they'll go backward, and they're keeping track of x now. So as we see, here x is equal z g, and they go like outside this function to see where this z come from. And as we can like detect it over there, z is as same as a, because we are calling this function with argument a. So if we are syncing information from A, we are syncing the information. So here, as we see, we have assigned A.G to B, and here we are syncing B.F. So what happens here is that we had this source W, and we tracked it, and we found its aliases, and saw here that the information is syncing. So the whole algorithm is that find the sources, see where they have been allocated to heap objects, go backward, find the aliases, and for each alias that you find, you should go forward again to like see if they're syncing or not. Oh, okay. Any questions with this example?
Do people have any thoughts about corner cases here, or how this might behave in the extreme?
Is there a threshold on the number of aliases?
I feel like you could end up going in circles.
Corner case.
Okay, that's a good first question. One, can you end up going in circles?
Okay.
You shouldn't
If
be
you
able to.
have recursion,
If you have recursion, we have this context sensitivity that gives us a certain amount of
You reach
information,
a
a
fixed
bounded
point.
depth of information. Yeah, you'll at least reach a fixed point on some of these things. Yeah. So you'll be conservative. You might say that you alias some things you don't, but in the worst case, then you have a false alarm. But it does mean that you'd have to trace back essentially to the beginning of the program in order to find all the potential aliases, right? So this is a little bit different than some of the other stuff that we've seen where you'll compute something as you go and just you compute everything at once and you have it at the end. This is what we call a demand-driven analysis, where for a given issue, where we see that W is sensitive and we're assigning it to x.f, we might do a lot of work at that point, but we'll only do it in response to that particular issue that we want to be informed about. And then we'll build up all that information about the aliases only as necessary. And we won't recompute the aliasing information that we've already recomputed. So if we need to know about the relationship between x and I guess z.g again earlier, that information will already exist now, but it's only computed on demand. And this is how a lot of alias analysis now works in practice. Maybe that was too much of a tangent, I don't know. That's
Yeah.
a very pragmatic, useful thing to know anyway.
Yeah, I think we'll go through it in this place as well. So how do they do the taint analysis? So there are 3 points to think about. So the assignment thing. So for example, here in the example, if A or one of its fields, doesn't matter, is tainted, we consider C as a tainted thing, tainted variable. Also, they mentioned that to be conservative when dealing with array assignments, they consider the whole array tainted, which later on we'll see it has a bad impact on the results. And also, when we knew a variable, they delete all the things that is assigned to it from before, because that information is gone.
Any thoughts on why they have to do that, use that approach for handling arrays? Why can't they be more precise than that with arrays?
Because they don't know which element to target.
They don't know which element is being targeted, yeah. And they could maybe do some extra work to try and figure out what the possible elements are that you're targeting. But it turns out that gets out of control pretty quickly. So just figuring out which element is being addressed falls down to something called range analysis. And you lose precision very, very quickly when you're looking at arithmetic. So it's tough.
Yes. So and also they have this on-demand alias analysis that you talked about it as well. And in the subsections they talk about how to maintain context sensitivity and also flow sensitivity. Okay, so here is another example. Okay, here they illustrate how context sensitivity is important. So the whole point that they are, the whole thing that they're pointing out here is this function tainted. It taints this value that gets in an argument, and and it syncs it out. So it's collecting this information, but what we want to know is that is this information important or not? Because as we see here, there are two function calls to this method. One of them takes information from the source, but the other one only has a string public. So if we get this information out, it's not really important. But this thing that comes from a source is important for us to detect. So, so that context sensitivity here matters. And yeah, and if you want to be more precise, so here, this argument, if it's tainted, we are allocating it to a heap object. So we should go backward and find the aliases, which is out. and we are syncing out. So yes, I think we can detect it, and also okay. And where does this out come from? Um, it is either P2 or P. Uh, yes, that will be, I think, will be detected as source of, that will be detected as source of input, I think. But the whole thing here is that we shouldn't care about this function call and only care about this one. So they'll have a follow-up algorithm to like how they handle this, which they call context injection. I think maybe if we take a look at that one, this example will be more clear.
So do people see?
In this, they were basically talking about how P2 should not be detected as tainted. The P2 sync P2.f
Okay.
should not be detected falsely as tainted.
Mm-hmm.
I think that was the whole gist of this example.
That was a big part of it. Do people see why that's true?
Because it's taking, the in is different. It's not the it's not the source. So the function tainted for P2.
Right. Right.
It's actually not leaking out the password. It's just something else.
Right. So this then gets to the notion of context sensitivity and why they care about context sensitivity. In one context, they're taking in things that are tainted. In another context, they're not. And so they need to be able to detect that.
It's clear what they're doing. It is not clear how they're doing it.
Okay.
What's the process behind it? Like, if I want to implement this, how will I do it?
Yeah, I think we'll see.
That is not clear.
It's
So-
open source. Come on.
Yeah.
Okay, so I think maybe better to have
This was
the
the tough
look at this.
bag.
So I don't know, this algorithm was in my version of paper, which I found in Google Scholar, but was not in the paper in the website. So I'm not sure which one you have.
was a preprint, but
That's why there are no authors.
Yeah.
right. Although usually the preprints have the same content.
Yeah, so here's the IPS algorithm with the, I think there's like change. I'm not sure if it was a change or not, but I think that so they have this like going forward and going backward main loops, and for each of them they have a work list which they'll go through. They haven't really discussed how this algorithm works, but the thing that they have emphasized is these two lines that are highlighted in here, which talks about how they inject the context of going forward to the backward search and vice versa. So how it works, remember we talked about when we hit a tainted heap object, we go backward to find its aliases, and for each alias, then we go forward. So I think these two additional lines are just doing that. So if we, here they have a diagram, if we go through this, so in the, so here in the naive approach, when they want to go backward, they do not insert the context of the current thing. So they will start with like a true fact, and they will go backward. But here they are inserting this context of in, which makes it to be context sensitive. I'm not sure if it's clear. If you have any questions.
The zero part is not true.
So the zero part is the true fact. If we start from here, it means we have no information from what has happened in this point that we are in.
Can we like have a very small example? Like,
Can you explain the diagram with examples before?
So the underlying approach here, this graph is how the IFDS method works. You can look at it as being almost like a circuit, and the zero is wired on.
Okay.
And so you can connect things that are true to the zero to wire them as on, right? And so then the question is, as you end up connecting these things together and turn them on, does that lead to some other thing which tells you that something is true, right? How does that feed into the facts later down in the system? So what this ends up meaning is that you have a way of expressing data flow analysis through graph reachability. Because if the two things are connected, then it turns on, right? So the naive approach that they suggest is essentially to say that when you start running this analysis in the other direction, well, you're running it in a scenario where a certain thing is true, and so you wire that from 0 to the underlying fact to say, this is true. The problem there is that if that's in the circuit, that means it's always going to be true. And so you lose the context information. So you wire one graph into the other. And this means that it's only true if it was true in the other graph. The context fed into it to say that it was true.
Yes, for example, if we go to the example, if we go to the naive approach, we will not detect the difference between these two function calls, and we will say, yeah, so we don't have any information. We come from the true fact. So both of them are detected as the vulnerabilities. But if we do the context sensitivity, which came from the in argument, it will detect that where did it come from. So it can detect this one doesn't matter, and we should only consider.
So what will be the zero graph for this one? 2 connected to line 2 connected to 3 connected to 4, 6, and 2 is also connected to all the tainted function itself. 8, 9, 10.
So questions?
There's a reason that I chose the other interprocedural approach to look at in class. But yeah, I mean, it ends up wiring things together more like this. The issue here, the underlying approach is made to be able to detect those sorts of issues as long as you're going in one direction. The issue is that they're feeding facts from an analysis going in one direction into the analysis going in the other direction, so they have to connect their graphs from the two different analyses.
Okay, so is it clear? Okay, so how do we maintain our flow sensitivity? So here is another example. Okay, can anybody think of why this example is illustrating flow sensitivity is important? What's happening here?
Do people remember what flow sensitivity is?
Well, because the first sync function doesn't have a source in it, and the second one does. The second one is tainted.
Okay. Which big picture just means order matters, right? That's flow sensitivity. Order matters.
Yeah. So here we are syncing. Oh, sorry. Here we are syncing p2.f, and here we are syncing it again. But this one doesn't matter because it doesn't have the sensitive information. When we assign it, when we get the information from source, that when it comes into play. Cool. And because P2 and P are aliases, when we assign a source to P.f, here P2.f contains important information. So when syncing it out here, we should detect it, but not earlier. So
Is analysis triggered by a source or sync? Does the analysis start from the source or sync?
It's triggered by the source, right? So this is, we looked at backward slicing, we're collecting all these dependencies. One of the things that I want to talk about also is that kind of the difference between taint analysis and slicing, where taint analysis just tries to be a little bit lighter weight and more pragmatic, which is part of the reason why it usually looks more at data dependencies as well, because that is lighter weight. If you include control dependencies, it becomes troublesome, scalability-wise. So you hit this source, right? And then we assign to a field. What happens when we assign to a field?
If it's a if object, we will find the aliases and go backward and find
Right.
the aliases.
Right. So we do forward analysis from the source, and that's traditional taint analysis.
Yeah.
Then we do backward analysis in order to resolve the aliasing.
Yeah.
And then from that backward analysis, what happens?
We go forward again.
We go forward again. Yeah. And so it's that backward forward,
Exploration.
yeah, that leads to imprecision.
Imprecision.
It leads to imprecision,
But also-
potentially, right? That's why we're looking at this example.
Imprecision? Or-
It leads potentially to imprecision.
Okay.
Yeah. So let's walk through that. Let's without discussing their solution yet, let's discuss what would happen without their solution to this problem.
What would happen is that both of them would have been detected.
Why?
So,
Why?
okay. So here we start from the source.
Mhm.
Okay, P dot F is tainted.
Mhm.
We go backward, find the aliases, which is P2,
Mhm.
and then we will,
So you connect the
We'll
graph
go-
to
oh, okay, I think I'm confused.
So
I should wait to see.
when I was checking the alias analysis,
Okay.
so it was like you check for all the aliases,
Mhm.
and then wherever they're used, that means the same alias is being used. In the sense, the same data is being.
Potentially, yeah. Yeah, it's an alias relationship. So a change to one could potentially affect any of the others.
Right. So that would have failed in this case, right?
How do you mean?
I mean, I checked the aliases for P first. I assign that P equal to P2. And wherever P2.f is being sent, that means P.f is being sent.
Potentially, yeah. Well, definitively in this case, yeah, that's just true.
Yeah, so then P.f is basically getting its value from source.
Okay.
So that's the wrong way to.
That is the reason for this
Right.
diagram. That is why they're showing it.
Right.
Yeah. So the issue here is that when you go back, right, we do the backward search and we hit P2 equals P equals P. So we have that relationship there. So now we do the forward search, right? Because this is the backward forward. So now we do a forward search from that point where we discovered the aliasing relationship to find potential leaks, right?
Yeah. So like they have mentioned that before, the tools would detect both these lines as
Right,
tainted.
right.
But so their approach is keeping track of something called activation statements.
Mhm.
So here when we go forward again, we will not report this line because it has not been tainted yet.
Right,
It
right.
will wait until it happens here and then it will report.
Mhm.
Number four.
So that entire thing is just keeping track of the order of things. They have to go backward in order to discover the aliasing relationships, and they have to go forward to find the sinks. But they don't actually want to report a violation unless they hit a sink after they've got sensitive information.
So why wouldn't you go back to find the aliases?
Mhm.
And when you go forward again, wouldn't you just start at line 3? When you start going forward, you go forward from there on in?
That's essentially what they're saying.
Yeah. Okay. That way sounds easy.
Yeah, but because the previous approach didn't do forward analysis again, when they did backward analysis, they would always say, okay, these are the aliases, so they are like vulnerable. But they go forward again to keep track of the flow. And so we'll go to the evaluation part. So they have these 5 questions. First, they'll talk about how, commercial trend analysis tools. Okay, which in this one they talk about how their approach worked in comparison with 2 other approaches, which they have a table, which I think is not clear. Okay, but anyways, they compare it to AppScan and Fortify on their own benchmark. Which I think the fact that they have done it on their own
Right.
benchmark is kind of.
Inefficient. So, AppScan and Fortify, they're not specific for Android, or are they?
Well,
I think they are.
AppScan is, Fortify isn't. Well, I think it was a special version of Fortify though. It might have been an Android specific version of Fortify.
It's
Let me
for
double check.
AppScan source. I think they are both for applications.
And they're doing it on their benchmark, which.
So the
might-
thing is, there is no existing benchmark. What would you do?
Yeah, that's the problem. They're free to define their own benchmarks because there isn't anything. But they're also free to define their own benchmarks because there isn't anything.
Yes,
And
that's.
they basically score better in the things they took care of, the ones the callback and the other ones that
Exactly.
I
Yeah, yeah. So we don't know how much of a difference those make in practice.
Which
Which
certainly
is
does not
apparent-
much.
Yeah, they did talk about those 500 applications, real-world applications.
They did. There were some misinterpretations of the real world application results as well. So AppScan is definitely an app scanner. Fortify has a non-app version as well.
It says Fortify SCA by HP is another commercial tool widely used by security analysts similar to IBM AppScan source.
Yeah, what I don't know is if SCA is a specific, is an app-specific version of Fortify. Fortify itself is just a very commonly used tool.
And in case of Fortify, they were like, it just found the bugs in the life cycle just by chance. It was not supposed to.
By heuristic. Yeah, by heuristic. Yeah, I mean, there's a semantics-derived approach to finding things, and there's a, well, here are some patterns that tend to occur approach to things. And the Fortify approach is more the, here are some patterns that tend to occur.
Okay, so if you want to go through the table, the first set of benchmark are testing arrays and lists. The star point means false warning. So as we discussed before, they were conservative about arrays. So here, Floodroid will conservatively detect 3 taint. 3 taint syncing. So, but the other one detected 2, which doesn't matter because, I mean, like, not that it doesn't matter. I mean, they're all false alarms, so it produced more false alarms than the other ones. And the callback set, as we see, Floodroid had the most correct warnings as they have handled it very good. And they were like all discussing how to handle the callbacks. Field and object sensitivity, all the 3 of them almost the same. Inter-app communication, Floodroid leaks 1. Life cycles, they got it all because they were good in life cycles as well. We don't even know if Fortify is modeling life cycles because we don't know if it's app-specific. And they run it also on general Java programs. And the results are like similar as well. And yes, so at the end, they have this measure of precision and recall, which they claim that theirs is the best.
Are people
86%.
familiar
I
with-
had this doubt with the
93%.
recall stuff. Recall essentially means that
First, are people familiar with precision and recall?
Yeah, I got familiar with it.
machine learning.
Okay, yeah.
So-
It's machine learning or information retrieval based
Right.
So
measures.
in recall, the denominator is basically the total number of true positives which you can
Mhm.
which you can find. right? So how do you know in an application that, okay, these are the total number of fonts that I can find?
If you're creating the applications, it's easier.
I think
Yeah,
they
but what about the real world and other stuff? They give recall statements for that. And that was not.
They didn't give, they didn't really give a recall for the real world.
They just gave time, I think.
Yeah.
Yeah,
They gave some raw numbers.
right. So
They
these
didn't give recall.
benchmarks, like,
For these, it's okay, because they're small they're micro benchmarks that they created.
so you manually figure out what are the total number of leaks that are possible and then you create. That's
They
not
have developed it,
efficient.
so they know already.
That's the underlying intuition anyway. In theory, they could have formally proven, with small benchmarks like this, that's possible. The question is whether it's worth it. You can do that sort of thing. You can actually prove that there are no information leaks in a given section. And the smaller the software is, the easier it is to do. But even then, it's formally proven with respect to a set of assumptions, like the assumptions that they made about Google's security policy and other things like that. And we don't know if those hold either. So,
So it's not really, like, you can't claim it as a very standard benchmark. The people will be relying on.
It is
You
standard
could.
for next week.
Yeah.
It's the only one.
yeah, it is regarded as good.
So generally when like people publish a benchmark, there is an entire paper on this benchmark based on what are the characteristics and.
That's
what
not
kind of-
true in this field. That's true in architecture, for instance. That is not true in software engineering. Sometimes you can do that, and there is a push toward more rigorous evaluation that leads to such things in communities like garbage collection, just because there have been some pathological evaluations. And so the community comes together and says, you know what, we need some good benchmarks because we don't have them. And so they come together and create these things. But for the most part, that doesn't happen in this.
Because you would not know how good the benchmark is without knowing the characteristics of it. And how it is like related to real world in the first place. Say if it is
Sure.
like very much real,
Mhm.
then okay, we can rely on this and then make, come up with new ideas which will suit this one. Now, in the first place, if you
This
don't
this
know
isn't
how
what you
good-
necessarily care about in the context of security, right? You don't want to say, does this reflect real world behavior so much as does this reflect the set of possible behaviors? What we don't know is, does this represent the set of possible behaviors?
Even that is not discussed.
Right, but that's what you care about more than is this
Yeah.
real? Because that's the question more of whether or not you're providing a good measure of assurance versus versus realism. Because
Right.
most of these things may not happen in practice, but if your app happens to be one that does, you care.
So I guess like they have a lot of material outside this paper. There must be one where they talk about total set of possible cases that can security vulnerabilities which this can handle, like which this exposes, and then you can rely on this and then create ideas.
I think they have like a documentation, something for the benchmark, because it's all available online on their website, so
Yeah,
I think there's questions.
there's nothing that goes into this deeper and says that this is representative of the real world.
Have you taken down the technical report for some reason? Which dimensions and everything?
Oh, that's
Mutual peer review something?
Wait, the technical report doesn't exist anymore?
No, it's taken down for some reason.
okay, that's interesting.
It was being reviewed by someone, I don't know.
It's possible that they're publishing another part of it, and as a result of just the blind nature of some submissions, they had to take part of the technical report down, because they published this part in one conference, then they published the other part in another conference. That does happen.
So, any questions with this table? We can move forward.
I agree that the issue of precision and recall is potentially biased by the fact that they're defining benchmarks.
But they get that. They're allowed that because they find the benchmark.
They're the first ones to create the benchmark.
Yeah.
Yeah.
So,
But there are like certain standard attacks which can happen. It's like if you go to security areas, you know, like side channel and all these are like famous ones, like standard ones. So if you could have something like, okay, these are the benchmarks, and this benchmark covers this attack, this benchmark covers this attack, and we are able to find these out of the total set. That would be a better way of evaluating.
It's tough to say. In general, taint analysis doesn't necessarily look directly for things like side channel attacks. That's not as much the purpose most of the time, just because it's more costly. There are more advances in terms of how to take into account dependencies like this, because for instance, this says, does this character equal something else? Well, that's a very strong connection. So maybe you actually want to add a dependence there because it's a tight relationship or something like that. There are approaches to that sort of thing. But in general, that's attack agnostic. Right? It's just about the information leaks. If you can detect the information leaks, then it's the properties of the program, not the properties of the attack, that are more related.
so the second question is about performance on Insecure Bank. So Insecure Bank is an application which I think it's famous for see how your analysis works good enough. And I think they detected all of the insecurities of Insecure Bank, so they did a good job. Next question.
Second one. So they did not mention what data leaks they found and how did the other apps perform. They did not compare their results with some other apps.
This is true. They don't compare their results against, say, Fortify and IBM AppScan on these same benchmarks. They only do that in table
Android.
one.
One.
They could have compared against the other approaches on those benchmarks as well. This is true. They broke it down separately where maybe they shouldn't have.
So the next question is more interesting. How this analysis work at real world apps? So they have mentioned some examples for which they did this analysis on Google Play applications. One example was about Samsung's push services, which it logged the IMEI number. So what is the IMEI number? It's like a unique number for your phone, which you can like take some number and get it if you want. I think it's 15-digit number, and it specifies your phone. So for example, if your phone is stolen or something, you can like that's how they track where is it. So it's an important information. So the Samsung push services are like this, and they figured it out. It was important that they claim the mechanism was changed in Android 4.1.
It used to be the case that logs were accessible to anything inside Android. So one of the approaches that malicious apps used to use is just read the logs of other apps.
Yeah.
And they happened to log sensitive information, which is stupid. Never log sensitive information.
Yeah. And it's almost recently, so it's kind of weird as well.
Yeah, well, it's not uncommon even now for not
I
necessarily
saw that
apps.
on website once that you could actually, so there are these file managers that comes. You just go there and go to a particular location, open the log,
Yep.
and you can see the security Wi-Fi passwords of all the passwords which are saved in your phone. And you can just note it down.
And even on servers now, one of the issues is that there's a risk of things like logging credit card numbers, just because people are stupid about what they log. And logging is an important part of any large software system. Very big bird, maybe. Anyway, but yeah, this is a very large problem even outside of mobile. people are stupid about logging.
I had issued that they choose 500 most popular Android applications
Mhm.
to try the tool on. Because popular applications,
I'd say.
it's not very likely they will be actively malicious.
But there will be other malicious programs which will be attacking those
Yes,
programs.
like reading the logs of something.
Yeah.
Granted, if they did
But
find
if you're not
something,
analyzing those other programs, it doesn't matter.
Yeah, but that is the important part which you should be analyzing because, and I think the other papers look at that where there are multiple applications. Which
Only a few do. That's more recent, but yes. That multiple apps where one offers permissions or something like this and the other exploits those permissions. Yeah.
Yeah. So there was another example, the game Hogo Runner, which is famous as well. So yeah. So this one logged the your location information to a preference file. I think luckily it was in private mode. So they just figured out this is important. Like other applications should be careful, not make it public.
so that was that was a false positive.
I'm not sure if they recorded it as if they reported it as a thing as a
True or false?
yeah. They just it just mentioned that it's important to be taken care of in like when you're developing applications.
No, in this case, the performance on real world. So it says that most of them contain 2 weeks, and I said that were they able to find it, and you say that's how we came to the number.
How else do you calculate that these apps have 2 weeks?
Maybe they already know.
You
No,
don't know.
if you start at the paper, they're known apps.
They're known apps because of the top, 500 in the App Store. So, okay, that's how they're known. That's it. So those average of 2 weeks those are their results.
Yeah. So
We didn't talk about leaks ever. What kind? Are there like there's only one type of data leak? That's it.
Well, they said that the IMEI number being sent to a remote server or SMS message.
Right.
yeah,
That's the type of leak.
any
Same.
kind of sensitive information that you care about.
So the IMEI number, I guess, is actually a very important number on your phone.
Yeah. It
'Cause
is.
it's your mobile identity.
Yeah.
And all advertising would be based around that number.
Right. A lot of it is, yeah.
And if you use Samsung's push service, which a couple people use,
Samsung is pretty notorious for not being a good player.
but they say that it's freely available, that your IMEI number is publicly available if you through the Samsung push service.
Yeah, or if you use an app that uses advertising services.
Oh, okay.
So pretty much, if you have an app, if you have a phone, it's identifiable.
Okay.
Just like if you have a web browser, it's identifiable. That's just given.
Okay.
This is true. No, this is just a true fact. Yeah, you are identifiable.
I have another point.
That's okay, I'm fine.
There's a line that says, nevertheless, the majority of apps were reported to probably leak the IMI thing, and they were not able to find it.
No, they were. That's how they know.
No, but that's written somewhere that said they were reported to leak, so they already know that they were reported to leak. It doesn't say
By
that
their
they-
system.
Yeah, they found.
They didn't say by their system.
That's the only way they can know. that's how they know.
They
Well,
just,
They probably should have been a little more precise.
Could it be possible that they already know what it's leaking and they're testing
No.
for it?
No.
Just to make sure that the tool works?
Well, no, in the virus share project, they would know what all the bugs were.
For which?
The
virus
virus
share
share
project.
project, which he's talking about.
Oh, is that what you're looking at?
Yeah, so he said we also ran Flowdroid on 1,000 known malware Samsung
Virus
samples.
share probably.
Yeah.
The virus share, and then in those they found 2 data leaks each. And so
Okay, yeah.
So they're supposed to know.
yeah, but that's they
They don't mention that they find it 2 weeks.
Oh, I see what you're saying, yeah. Say,
They say that it's supposed to have 2 weeks, and they don't say that they find it.
I assume that's
Nitpicky.
what they,
No,
That's fair. I mean, they should have been more precise.
they don't
I
claim
guess.
anything that they found it.
yeah, they don't, it's unclear whether they're talking, if they're describing virus share, or
Yeah.
they're describing their results.
Right.
Yeah. I mean, they probably should have been a little bit more precise in their wording,
Right.
but that's.
But this did have the little artifact evaluated, but I don't know how that, it's a little sticker on the top.
So it means their software is available and their tests are available, and people looked at them and said, hey, this is actually something that can be used in reproducible science.
Could be a potential term project.
Okay.
Yeah, I mean, we've seen that a couple times already, right?
So they claim that their approach was pretty fast, and it works in seconds, which is good, under a minute. Okay, now we go to the next question, security bench micro, which they have a table. What? Which they have a table, which tells us the true positives and false positives in different groups, which I think it's good result.
Is it the same thing as the previous one?
It's a,
Security,
I think it's another thing.
These are different.
yeah.
Yeah, this is a separate
It's a
standard
separate thing. Yeah,
non-Android security benchmark.
and
So
there is benchmark.
yeah, there are benchmarks.
Not for Android.
Specifically.
Yeah, these are non-Android benchmarks.
yeah, and
Well, then they could have run the other tools on the non.
They should have done that. Yeah.
yeah, but they claim that everyone refused to.
Not the tools they had, the IBM Scan and 45. So
Yeah,
they
Oh,
could
yeah.
have run the test themselves.
yeah, true.
Could you go back to that security bench?
Which
So they just talk about true positive and false positive, right?
they're just reporting the number of true positives and false positives.
Because you
Of
have to,
their
have to
approach.
know statically
Decision.
which elements are being accessed.
Huh?
Yeah, I don't think they know how many,
And you don't even
do
know
they,
the size
you're
of
asking
the array.
prior to that, it's not recorded.
Why they don't have it?
There's something in the
What?
experimental results which
So-
is not known because of
So they're just talking about true positive.
why using arrays.
I assume
in
that they have a
manner
secure
is hard.
bench,
I
there's
understand
no,
why they are having that imprecision there.
the number of, oh,
How
no,
will that affect their results?
What?
Is
What's
it
the
because
They're really
collections say that there
I
are
don't
false positive?
they're only reporting positives, true positive, and false
There-
positive.
there should
What
be
about
false
negatives?
positives because of that imprecision.
But, like, true, they got,
But the negative scale are from, right?
Yeah,
It's 3 out of
it's-
3, so.
yeah,
Hmm?
which is, never mind.
No.
I don't know either, so.
I've lost myself.
You have to see the program to understand. Well, was there a second question?
So it's why they haven't reported the negative ones.
But we realized it is, so it's okay. We gave up on the question. Sorry.
What?
Exactly.
Why did they report the negative, false negatives and true negatives? Just positives. Why?
Ah, okay. And you figured out why the question might not have made sense.
Yeah.
Good.
Yeah, so, okay, thank you.
Gracias.
Basically, don't trust your phone.
Or your browser, or your computer, or anything.
Don't go on the internet.
Yeah.
Don't have a wireless
Even
connectivity.
things like,
anything.
which websites do you access?
Don't
Can
cherish
be,
your privacy.
There's been a lot of
Based on the
assume that
color
you
of
have
the
that.
HTML, you know,
There's been
color
just
of the
banking
applications,
applications to
you
mobile.
know.
I'm not stealing it anyway.
Why not? There are things known as super cookies, even.
Just don't
which
keep
are
on policy.
constructed
I'm
to
using
Flash.
Actually, that's not possible.
Yeah.
That's true.
But like
You know,
there's so
basically,
many
if you're trying to delete one thing, they're gone, that's why
Credit card?
the operating system is
Yeah.
an integration. Not a brand name, it's an operating system, it's another stuff. all this stuff feeds.
Okay,
the
there's not a
to
whole
narrow
lot you
down
can compare, I
how
guess.
many
The
people-
only